Lesson, CLevelAE. CLevelAE is the ability to launch spacecraft from any altitude, not only sea level. So, the formula goes like this. Vector of lost gravity equals the square root of 2u times h over radius of Earth times radius of Earth plus height times zenith. Then you have the vector of arrived gravity equals the vector of lost gravity minus 100%. Then you have 0 over 100 undefined times first number plus last number divided by 2. Then the speculative formula. That is the formula for CLevelAE. Those that have seen the burnout burnoff, this is a variation of that specific formula. Let us now break down this formula. Our first portion allows any launch altitude onto any orbital altitude. Our vector of lost gravity is our personal, where we live, squared, remember Kepler, relativity based upon gravity. The 2u is Earth's gravity constant. The h is the orbital altitude. The radius of Earth times the radius of Earth plus h is 6,378 kilometers plus h, which is the orbital altitude, or the destination. The place where we're trying to get is h. Okay, square root, we know that it's kind of like a phase shift and just lets us know what's going on numerically. Our zenith is technically true up, and it's also when you lay x and y flat, you get 3D dimension, which is z. H in this instance equals 1.922 AU, or 287,575,515 kilometers. That number is unique to this demonstration. It is, as of May 16th, 2024, the distance to Mars. Meaning that this demonstration, this LDD leaf pilt, is going to be on the surface of Mars. Now I know you'll say, well, orbital, and that's not orbiting, you're just putting it on the surface. I know, but we've also already done it using orbits, and I just want to show it that you can also land on the surface as well. So this leaf pilt is going to be on the surface of Mars. From Earth at any altitude, I'm going to also repeat, remix, remain it once a week, every Monday for 86,400 for fellow astronauts who want to see it, want to not lose their hands over it. Okay, so when we plug in this formula, we have the vector of lost gravity equals the square root of 3.986 times 10 to the 14th meters cubed per second squared, divided by 6,378 kilometers times 6,378 plus 1.922. Grand total, handless drum roll please, 249,989.38. Then we take our vector of arrived gravity to equal our vector of lost gravity minus 100%. This is for arriving gravity atop departure gravity. Arriving gravity is from anywhere in our square that isn't our square. So our departure gravity is our square. What we're doing is we are injecting gravity from the whole, technically from the solar square. You can do it from anywhere in the solar system. This demonstration, LDD leaf pilt, is for using the solar's gravity. So basically, in wordy words, we're taking our vector of lost gravity from 100%. 100% is from TIH, true integer heliocentricity, triumphant, that are atoms, charged particles, photons, radiation to BCF, as well as and due to solar's Oort magnetosphere border cloud that allows in the TIH. That's what we're trying to get into. So we're furthering the reach by also using 100%. Okay, also, another reason we use 100% is that 99.86% of our solar system's mass is from the solar. We round it up to 100% because if the solar stopped shining within undefined amount of time, all that 0.14% would cease to exist eventually in an undefined moment, but would happen no matter what. Defined would happen. So that's another reason we round it up, because truly you can't survive without. So all of those things are what gives us the 100%. So we take our 249, I'm handless, I don't know if you noticed. We take our 249,989.388 from 100%, and we get 249,889.388%, which is a Hertz plume. And we're in our solar system, which is DH, and it's absolutely tragic. So we use the absolute value of DH, which is tragic negative. So it is negative tragic 249,889.388. And that Hertz plume is against C pi T, which is TIH prerequisites. Do not forget that perfect angstroms is 0 and it's triumphant and it is greater than tragic 249,889.338 tragic DH. Then we take it 0 over 100 undefined. The undefined is all of these words from here, and it's also given the, yeah, that's exactly what it is. It's all of that stuff undefined yet. It's like coming into the fold. So how we would determine it if it wasn't undefined, and just to let you know, like for a really long time it's going to be undefined. Like, it's better to just think of it undefined because it's so fetched in the far when it becomes defined that we're just, think of it like once we could actually create a Dyson sphere, that would be the time where it was defined. Think of it like that extremity, like it's just going to be undefined until then. So you're safe just calling it undefined. But to give you where the number comes from, we take the 0.14, which is the missing solar mass of 99.86, and we subtract our square, which is 0.003 of the 0.14%. And that gives us our 0.137 over 100, which is undefined because it's such a negative value. It's minus e to whichever value's up there. Regardless, it's undefined. No Dyson sphere. Clean, simple, ready to go. Now we start plugging in our first in plus last in. And what we do for these are our first number, we take 99.86 and we inject our square into it, which is 0.003. Gives us 99.863. That's our first number, first in. Our last in, what we do is we take that 99.863 plus the tragic 249,889.388, giving us 249,789.5252 tragic DH percent divided by 2. There will also come a time when we divide it by 3. We're just not doing it yet. That's TIH technology, but we're in the solar system of DH. Quick tangent, but it's by 2 right now. Okay, so divided by 2, that gives us tragic DH 124,894.762, which is the solar placement of tragic Hertz A plume, angstrom plume. Then, a lot more of this will be explained during the speculative formula. I just want to give you a little bit heads up of the numbers itself. So on this linear graph over here, we use static fires because they are like, I mean, it's how it's testing in rocket engine. If it's ready to take off, and it's got the same force of it, etc. It's just grounded. What we do with the Hertz plume, the tragic Hertz plume, which we know that the tragic DH 249,889.388 is the tragic Hertz plume, like the atoms that are disallowing us to launch to the leaf pilt Mars from anywhere at any altitude. That's how much tragic angstroms are holding us from able to do it. We know the break-even point is 124,894.762, which is a tragic DH that we're CF into triumphant DH. And once we reach that amount, it's greater than the tragic 249,889.388. So we use static fires. If I'm just sitting here, how it'll work is I say static fire, and that gets us closer because it burns up using the energy of the liquid propellant to start to get rid of those tragic Hertz plumes. And we do that because we, again, we inject the CF intention using speculative for that to burn up those Hertz atoms, right? In which case we replace them with our Hertz energy source. Burning up the atmosphere, exactly, burning up the atmosphere. Okay, so static fires is our X, and our Y again is LDD. Instead of sequences, we just do, like I had said, the whole sequence is 86,400 on a Monday. So instead it's static fires that gets us to that place, and it's 3 static fires that are at a specific time, which will get us to LDD1, which is the place where this angstrom battle, where it turns the page, where we get ahead of it from tragic into triumphant. In which case LDD1 of 2, we're maintaining it, and LDD2 is only there. So think of LDD1 as where the static fires take place. LDD1 of 2 maintains it, and LDD2 keeps going. It never had any tragic. Plugging it into the speculative formula. So our F equals LDD1, AR equals LDD2, force on surface equals 1358 watts per meter squared. Our C pi T is our leaf pilt, which is every Monday 86,400 sequences for all of them. Our area surfaced is LDD1 through 2. Our 1 plus P equals our 3 static fires. Our cosine is 90 degrees. Our diameter aim and our height equals our from the solar onto Jupiter, which uses its core to send it out to Earth. So that gives us our capitalized repeat remain remix. Our P equals 0 angstroms. Our hertz is all the intention that you blast off from anywhere. All those numbers, all that energy and thoughts we put into, that's our hertz intentions. It's being able to launch from anywhere. Yeah, you can, yeah. All right, our 25 Z-Rot equals 0 over 25 per ppf tap per LDD 1 through 2. And our stec.MPA is our sine oath. So from doing all of that, we get our ain roared. Where's the dolly? Our V ain roared is Monday's Mars 86.4 static fires.